Hello and welcome to the Academic Center for Writing presentation on writing a project proposal. This is part 1. This presentation was written and narrated by Jason Schneider, writing specialist in the ACW. In the introduction, begin with describing conspicuous observations that interest you. These obvious occurrences you witness might be more complex than what is observed without analyses or tests. For example, a rolling ball or a similar object that can roll seems fairly simple when we watch something tumble down an incline, or in this case, we might observe someone dropping objects from far above and take it for granted. Galileo investigated these kinds of things and found that there are more complex, if not rich, laws at work within the field of physics, such as why both a heavy object and a light object fall at the same velocity despite the weight of the objects. In writing, you should describe basic observations and possible issues at work. Another example we can bring up: a ball attached to the top of a rod on a cart might seem to fall straight down as the cart is moving, but after investigating the phenomenon, it is actually more complex because the ball falls in a curve rather than a straight down. So, in order to kind of show these observations are a little bit more complex than what you might think, and this is why it's good to include in the introduction some simple observations, because we take them for granted. Watch this for a second.
I'll show you this again. This time there'll be a line on the film so that you can see the path. I think that you can see that the path of the ball is a parabola.
Now that you've seen this, that everything is not straightforward. Secondly, you must articulate a research question for what you intend to investigate. There should be a motivation included with your research question. A motivation could be something said from research you have done, or an oddity you have noticed observing without any experimentation. Just like if we were to watch the ball in a cart fall, without actually analyzing this, we would say, yes, it falls straight down, or does it? Lastly, you will need to predict what will happen and not happen. The prediction that your hypothesis is wrong or unsubstantial is called the null hypothesis. The null hypothesis should be able to falsify your hypothesis. Your hypothesis should rest on the alternative hypothesis. This is what we actually call your hypothesis. And that is, the alternative hypothesis is what you are predicting to happen from the experiment you intend to conduct. But first we need to actually look at independent and dependent variables. We have a dependent variable, which we may call a factor as well, that is the thing being measured. Secondly, independent variables are things that we are manipulating in the experiment. For example, let's say that we wonder which bug is better suited for a particular terrain. We might decide to manipulate the terrain by making it either smooth as one level or cluttered with a bunch of rocks as a second level. Therefore, we would have terrain as a variable with two levels, smooth and rocky. Though this is maybe not a fruitful experiment, we can measure how quickly our bugs travel across each terrain to find which bug is better suited for traversing across a particular terrain. Let's visualize this. We'll need to specify our variables, as we already kind of said. Remember, the independent variables are the things that we control and manipulate in the experiment in order to see a desired effect. One independent variable must have at least two levels. In textbook talk, a variable is any characteristic or quantity that can take on two or more variables. The relationship between your variables that you expect to uncover in your experiment must be stated in your hypothesis. The ability to discover that a relationship does not exist makes the scientific method the powerful tool that it is. Therefore, here we want to know the relationship between our two independent variables, bugs and terrain. Those independent variables will have two levels each. The independent variable bugs will consist of one level being water bugs and the second level being stink bugs. Likewise, the independent variable terrain will consist of one level being rocky and the second level being smooth. Once you do your experiment, you can fill in the column for the dependent variables with the time it took for each bug to traverse across a particular terrain. The alternative hypothesis, that's what you are predicting, is what we are predicting here. It begins with an if clause and followed by a then clause. The null hypothesis is the same except that it includes not, or some form of negation that makes the statement opposite to the alternative hypothesis. An important distinction should be made between a directional and non-directional alternative hypothesis. The directional alternative hypothesis should state the direction of the dependent variable being measured and what that it'll take as either being quicker in our hypothesis about agile and limber bugs, whereas non-directional alternative hypothesis doesn't specify a direction, whether we predict our bugs being quicker or slower. Why is this important? Well, if we use the non-directional alternative hypothesis to find an explanation or conclusion, we'll be out of luck. A non-directional alternative hypothesis is better suited for observing a phenomenon without knowing what could happen other than some difference, effect, or relation might happen. This is just a template for writing a hypothesis. All you have to do is fill in the blanks with what you're testing for in your experiment. The introduction will follow APA format, where introduction is centered above the previous research, background information, or observations you have made previously. Then include subheaders, research question, and hypothesis aligned to the left. In Part 2, we'll discuss the methods section in detail that comes after the introduction. Thanks for watching. For questions about this or any other writing topic, come and visit the Academic Center for Writing in room W114. Thanks again.